Global warming juggernaut, the defining answer to the global warming question. We now know that continent shapes and mountain ranges are the causes of ice ages and ice-free periods. A great drop in greenhouse gases can also cause an ice age, but only the appearance of new mountain ranges could absorb enough of the greenhouse gases for a temperature drop. A complex carbon dioxide exchange between zooplankton and phytoplankton absorbs tremendous amounts of carbon dioxide, and plankton provides Earth's atmosphere with most of our oxygen. A mass die-off of plankton would cause a carbon dioxide buildup, and even with our forests, Earth would start running out of oxygen in about 10,000 years after the die-off. Within ice ages, greenhouse periods or interglacials and icehouse periods called glaciations are probably caused by Milankovitch cycles. And of the 720 billion tons of carbon dioxide in Earth's atmosphere, humans produce 6 billion tons, less than 1% of the total. The Cenozoic Ice Age is at least the fifth ice age that Earth has experienced since the planet formed about 4.55 billion years ago. Just within the Quaternary period of the Cenozoic Ice Age, there were at least 8 glaciations, and we are currently in the 8th interglacial. Scientists now think there have been more than 20 of each during the Quaternary. Erosion and decay make geologic dating extremely difficult and error-prone. For now, let's just try to make sense of the larger concepts concerning this ice age. This interglacial in which we now live is called the Holocene epoch, and it began about 11,700 years ago. At the start of the Quaternary, glaciation and interglacial cycles span great lengths of time. The first glaciation may have endured about 500,000 years, while evidence shows that the interglacial that followed lasted about 200,000 years. Subsequent cycles have fluctuated in length, but records indicate that interglacials are getting shorter and their temperatures are getting more intense. In other words, interglacial periods are becoming shorter and hotter. For example, the interglacial before the Holocene, the Eemian, was only about 17,000 years long. During the Eemian, Earth was about 3 degrees Fahrenheit warmer than today, yet atmospheric carbon dioxide was lower. We can see the lengths of the cycles by the marine isotope stages. Marine isotope stages determine the dates and lengths of the glaciations and interglacials. As with everything in climatology and geology, there's a margin of error. The even numbers are the glaciations and the odd numbers are the interglacials. Glaciations have higher oxygen 18 to oxygen 16 ratios in deep water shellfish deposits which are made of calcite. As ice sheets expand, they absorb more oxygen 16 from the water, leaving a higher concentration of oxygen 18 for marine organisms to absorb. What we are looking at are the marine isotope stages for the past 2.5 million years. The large peaks represent interglacials. It seems that the stages are not well defined, and I have not seen 2 MIS charts that have the same time spans for the same stages. Still, here are a list of several major interglacials and glaciations. Another list puts MIS 11 at 63,000 years long and MIS 9 at 33,000 years long. Subjective interpretations of the evidence is one reason. The other reason is that climatology and geology are sciences in their infancy. They both have a lot to learn before they could say anything with confidence. What then was happening during the Eemian? The Eemian was probably the warmest interglacial of the Quaternary. Toward its end, just before the Worm Glaciation, the Wisconsin Glaciation in North America, sea levels were 13 to 20 feet higher than today's levels. The Greenland ice sheet had melted, along with the ice surrounding the North Pole. Broadleaf forests grew to the Arctic Circle. The only permanent ice remained in Antarctica. Yet the polar bears and penguins survived. Moreover, these events occurred without the least tampering from human beings. And then, when the worm glaciation arrived, it was all gone. Glaciations, it is important to mention, are not unceasingly cold, nor are interglacials unceasingly warm. There are short warm periods called interstadials and short cold periods called stadials within these longer cycles, usually caused by indirect or unrelated reasons, such as the collapse of an ice sheet or a volcanic eruption. What may the Earth expect for the remainder of the Holocene? For the moment, let's say that humans play no part in climate change. Let's say that humans are environmentally neutral. Scientists know from climatic records that interglacials have been getting warmer, so it is reasonable to expect the global temperatures to rise at least another 3 degrees Fahrenheit, probably more. The records also reveal that interglacials have been getting shorter. Thus, if the Holocene is currently 11,700 years old, it makes sense to expect a new glaciation to begin in less than 5,300 years. Further evidence confirms the shorter span of the Holocene and offers greater insight. As stated by my old professor, Dr. John Navarra, in Contemporary Physical Geography, sea surface temperatures in the southern hemisphere have already cooled to the glacial stage. The evidence indicates that the accumulation of ice in the northern hemisphere lags behind the sea surface temperature drop in the southern hemisphere by about 3,000 years. Paradoxically, air temperatures will continue to increase, thereby melting Antarctic ice. Nevertheless, it appears that the Holocene epoch will have spanned about 15,000 years before it reaches its end and begins to cool down. I'm sure opposing sides have data to counter what I'm now presenting. However, if we just step back and think, the Holocene should be the shortest and hottest interglacial of the Quaternary period. And it looks like it might be. And it should end in the next 3,000 to 5,000 years. The signal for the final 3,000 years of the Holocene, it has been determined, will be the cooling of the sea surface of the southern hemisphere. And it looks like it's begun right on time. What should be expected for the next 3,000 years? Through the analysis of past patterns and the latest available data, it is not difficult to extrapolate. Temperatures will rise to worst-case scenario levels. The only permanent ice will rest uneasily in Antarctica. Latitudes nearing the Arctic Circle will become subtropical. Sea levels will rise at least 20 feet. Diseases will be rampant. Animal species will undergo upheavals, but nothing that has not happened in the past many times. Humans, though, will continue to populate, more like overpopulate. The interglacial is here. It is a juggernaut called the Holocene epoch, and there is nothing on Earth that can stop it for the next 3,000 years. Then, just as the flame is extinguished, it will be over and the next glaciation will begin. And when that happens, the human die-off will be like nothing anyone can now imagine. As planetary temperatures steadily increase, more and more gases will seep up from the surface and find their way into the atmosphere. It is no wonder that the atmosphere of Venus can crush a space lander. On a lesser scale, it was no different during the Eemian, but that did not stop the worm glaciation. When the next glaciation declares its arrival, the Holocene will come to an end and the problematic greenhouse gases will be reabsorbed by the depleted ground and water. Rest assured, there will be periods of cooling that will confuse some and galvanize others. But the overall course of the Holocene has already been decided by the Earth itself. Thank you for watching. And please don't forget, coming to booksellers, this 2023 holiday season, the coming of the seraphim. See you soon.